Okay, good morning 11th class. Then in earlier video we have learned about merits of Bohr model, and in that one our fourth merit was, if you remember, that one is Bohr model successfully explain the spectrum of hydrogen and hydrogen like ions, either it's a He positive or either it's a Li2 positive. So basically explain the spectrum of hydrogen. Okay, and you know that Rutherford failed to explain stability and spectrum of hydrogen, and Bohr model successfully explained, Niels Bohr explained that stability of atom as well as the spectrum of hydrogen. Okay, so today simple it's an explanation of spectrum of hydrogen atom by Bohr theory कि उसने किस टाइप से जो है वो क्या किया था स्पेक्ट्रम को एक्सप्लेन किया. Okay, although we have learned Rydberg equation, okay, and later on we'll study this thing कि Bohr gave almost same equation just like it's given by Rydberg equation. Okay, and different series were obtained like Lyman series, Balmer series, Humphrey series. So all these explanation by Bohr. Okay, because different scientists they observe different spectrum या different series. Okay, and on the basis of their name, simple उसके बाद उसको क्या कर दिया था इन्होंने, उसी सीरीज को साइंटिस्ट के बेसिस पे नाम दे दिया. whatever is the name of the scientist, then the name of the series observed by that particular scientist, तो वही नाम उनको भी मिल गया. Okay, now just see in this one, first of all spectrum. So if you remember, okay, in case of spectrum we have learned about spectrum. It's a two type. Okay, continuous spectrum, you know, when light pass through a prism, then it is split into 7 colors. Okay, and colors, one color will merge into another one. Okay, and if that portion is not clear to you, so you can see watch that video, okay, in which a spectrum was explained. In that one both the spectrum was explained. It's an emission as well as absorption spectrum. Okay, now in case of emission and absorption spectrum, okay, you know, hydrogen spectrum, okay, obtained when there is emission spectrum. Generally when we are talking about hydrogen spectrum, so we are talking about emission spectrum of hydrogen. Now in case of emission spectrum, how emission spectrum is formed in case of hydrogen. Now just see simple general thing. Now suppose this one is your nucleus, okay, and this one is your first shell, second shell, third shell, fourth shell, fifth shell, like this and so on. Okay, I'm not making full one. This one is only for the explanation of that electron, what happened when electron gain energy and all. Now suppose in first shell, now suppose electron is present, that in case of hydrogen only one electron is present and that one will be present in first shell. Now you know in case of Bohr theory, what was the postulate? थोड़ा सा रिवाइज करें. दैट वन इज इन केस ऑफ पोस्टुलेट, इफ यू रिमेंबर दैट इलेक्ट्रॉन कैन जंप फ्रॉम देयर शेल, मीन्स they can change their orbit only when they gain or lose energy. Okay, means when you provide some energy or either they lose some energy, then only electron are able to change their orbit, otherwise it will revolve around the nucleus in a fixed circular path, and that one is a stationary path. Okay, now in this one, now suppose this electron absorbs energy. Okay, either how it absorbs energy when we pass either electric current, कुछ electric discharge वगैरह दें. Okay, and this electron absorbs energy and it goes, it depends upon energy. Okay, and then it jumps from lower energy to like this one, lower energy to higher energy one. Now just see, this one is means from lower one to higher one. अपने normal orbit से lower orbit से किस में चला गया, higher orbit में चला गया. Now it depends, वो कहाँ जा सकता है, वो यहाँ भी जा सकता है. Okay, maybe वो यहाँ जा सकता है, maybe वो यहाँ जा सकता है. It depends on energy कि वो किस according क्या करेगा, अपना orbit छोड़ के वहाँ चला जाएगा. Okay, but remember one thing, this state, that one is known as excited state. This state is for a very short time, बहुत छोटे टाइम के लिए होते हैं. इवन यू कैन से कि ये मैक्सिमम कितने टाइम के लिए वहाँ रह सकते हैं. दैट वन इज अराउंड 10⁻⁻8 सेकेंड, इतनी देर के लिए रह सकते हैं. आफ्टर दैट व्हाट हैपन, इट लूजेस एनर्जी, ओके, एंड इट कम्स डाउन. आफ्टर लूजिंग एनर्जी इट कम्स डाउन. ओके, एंड व्हेन इट कम्स डाउन, तो सपोज अगेन दिस वन इट्स okay, that one is different shell. So when it comes down, so it depends कि वो कहाँ तक आ सकता है. हो सकता है that will lose energy and come down like this. up to first one. Okay, maybe it comes down like this, यहाँ तक ही आए खाली. Okay, it depends. This one is maybe it come up to another orbit. Okay, तो it depends कि वो कहीं तक भी आ सकता है, because these orbits are permitted. ये सारे orbits कैसे हैं? Permitted हैं, but not in between. वो बीच में नहीं आ सकता, but whatever is the orbit permitted, after losing energy वो कहाँ आ सकता है? नीचे आ सकता है. And when you observe this, when this emitted light, okay, when it lose energy, then when you see it in photoelectric plate, when you pass that emission light through spectrum, through prism, and then see that one is in photographic plate, okay, so you will get a spectrum of hydrogen. Okay, and how it looks, that also I'll show you. Now just see, this one is emission spectrum of some elements. So in this one the emission spectrum of hydrogen is also given. Okay, now just see, you have different lines. Just see, different line, that one is separated by dark color, that one is black color, and you know these lines are same. जो क्या किया था, absorption, when they absorbs energy, तो जितनी उसने absorb कर ली थी, तो after that when it comes down, तो जितनी energy lose करी सिर्फ हमें उसी के स्पेक्ट्रम ही मिले हैं, and they have some particular wavelength. Okay, they have different series, and they are all are of some particular wavelength. Okay. Okay, 11th class, now just see, have you seen that spectrum of hydrogen? Okay, now there is one question. In case of hydrogen, okay, there is only one electron present. Okay, if there is only one electron present, okay, so there is a simultaneous, if you remember that lots of spectrum we get. Okay, so why it's so? If one electron is there, तो several spectral line, how it arise, कैसे दिखाई दे रही है हमें? Okay, and for this simple reason is actually whatever you will, whatever is the sample of hydrogen, जब भी sample आप लोगे, even it is in very small amount, still it contains large number of hydrogen atom. थोड़े से सैम्पल में, बहुत स्मॉल अमाउंट ऑफ सैम्पल में भी वी हैव लार्ज नंबर ऑफ हाइड्रोजन एटम, एंड if large number of hydrogen atoms are present, it means number of electrons are present for different hydrogen. Now in that case, okay, that hydrogen atom, okay, yeah, their electron, they absorbs energy of different, they absorb different energy, and accordingly they jump. Okay, maybe they jump from first orbit to second one, maybe third, maybe fourth, it depends कि कितनी energy उसने absorb करी, and accordingly it jumps from there, okay, first orbit to another orbit, and when it lose energy, then it comes down. Okay, and it comes down to different orbit, either it's a second orbit, third orbit, fourth orbit, it depends. Now just see, for different spectral series of hydrogen atom, now this one is a simple representation. One side it's a wavelength, and here this one is energy. Now this one is n is equal to 1, n represents orbit. Okay, this one is first orbit, second orbit, then this one is third orbit, fourth, fifth, sixth, seventh, and so on. Okay, now just see, here gap is more between first and second, the energy gap is more between first orbit and second orbit. Here it's less as we move up, means as number of orbits increases, the energy difference is low. That you can calculate, because the formula of energy of different radius, that one is already explained to you. Okay, and when you want to calculate energy difference, for that also we have formula. That one is simple. If you want to calculate that one is delta E is equal to, or either you can say ionization energy, so that one is equal to, that is E infinity, okay, and that one is E n. This one is up to infinity, and you can take it as n, means whatever is the orbit, either it's a first orbit, second orbit, it depends कि कौन सा orbit है, so accordingly you can use this formula for numericals. Okay, now just see, in case of hydrogen spectrum, now suppose after absorbing energy, okay, it goes up to 7th orbit. Now just see, this one is up to goes, and when loses energy, so it comes down, maybe like this, Okay, maybe that absorbs energy up to sixth one and goes like this. Now this, okay, then maybe up to fifth one, कहीं तक भी जा सकते हैं. 7 से गए तो 7 से नीचे आ रहे हैं, then 6 से, then 5th and then 4th. Okay, now just see. Okay, this one is a spectral line. Now this is, okay, which when electron comes back here, jump from that higher one to, okay, that one is first orbit. This series, when you get the spectrum of this series was first observed by Lyman, okay, and that's why this series is known as Lyman series. Okay, this one is Lyman series, and if you remember, this series lie on which region? That one is in UV region. Okay, like this we will get another one. Okay, just see, that one is maybe electron jump up to 7th 8th orbit, higher orbit, कहीं तक भी चले गए. Okay, and when it comes down, जब lose करी energy, तो वो सिर्फ कहाँ तक possible है, कहाँ तक पहुँचे? That one is like this, up to second orbit only. Now just see, second, like this one, okay, like this. And this series, this one is known as, this one is Balmer series, and you know that Balmer series first observed by Balmer, and this series, okay, fall on which region? That one is on visible region. Okay, like this we will get, okay, bracket, fund, okay, the different series will get Humphrey series. Okay, now in this one, okay, now just see, like Lyman series, Balmer series, if electron come, okay, up to third orbit, okay, so this series is known as Paschen series. Okay, this is spectrum. If up to fourth one, so this one is bracket, and this one Paschen series fall in IR region, same with bracket. And another one, if it comes up to only fifth orbit, so this one is P fund. Okay, but we can't say P fund, it's a fund series. Someone says it's a fund series, but this one is fund series. P is silent. Okay, and this fund series also fall in which region? That one is in IR region. Okay, there is sixth or series also, and that series is Humphrey series. And for Humphrey one, that one is n is equal to, okay, up to this, कहाँ पे लाएगा इलेक्ट्रॉन, कहाँ तक वापस आएंगे? That one is up to sixth orbit, and that series is known as Humphrey series. Okay, and for Humphrey, after this, after Humphrey series, now in that one just see, energy difference is very very less. Okay, and if you go up and up, तो then there is a cluster of orbits. Okay, तो वहाँ से जो है वो स्पेक्ट्रम को देखना थोड़ा सा मुश्किल होता है. Okay, तो अभी तक हमारे पास कितनी सीरीज है? That one is 6. Okay, 5 series was explained by Bohr model, and 6 series also that they observed, okay, by Humphrey.